In this presentation, we will talk about Green's theorem. The Green's theorem is described from our Gauss divergence theorem. That is A dot ds surface integral, which is equal to div A dv. It's a transformation from surface integral to volume integral. See, this is equation number 1. Consider that pi and psi are the scalar potentials having their continuous derivatives at least of second order. Let A equal to pi great psi. If you consider pi and psi are two scalar potentials and are having continuous derivatives at least of order 2, second order derivative. Now we may replace A by means of pi great psi in the equation 1. Now equation 1 becomes pi great psi dot ds equal to del dot pi great psi into dv. Now we have to find out the value of del dot pi great psi. I into dou by dou x plus j into dou by dou y plus k into dou by dou z is the value of delta dot pi into this is I into dou psi by dou x plus j into dou psi by dou y plus k into dou psi by dou z. See, this is pi. Gradient operator is I into dou by dou x plus j into dou by y plus k into dou by dou z, and is allowed to operate on psi. So this is great psi, which is equal to I dot I 1. Therefore, pi into dou by dou x of, see, this change it as dou by dou x of pi into dou psi by dou x plus j dot j 1 dou by dou y of pi into dou psi by dou y plus k dot k 1 dou by dou z of pi into dou psi by dou z. Now we have to differentiate using UE formula. This is equal to dou pi by dou x into dou psi by dou x plus pi into dou square psi by dou x square plus dou pi by dou y into dou psi by dou y plus pi into dou square psi by dou y square plus dou pi by dou z dou psi by dou z plus pi into dou square psi by dou z square. Now combine all the terms. Dou pi by dou x dou psi by dou x plus dou pi by dou y dou psi by dou y plus dou pi by dou z dou psi by dou z plus pi into dou square psi by dou x square plus pi into dou square psi by dou y square plus pi into dou square psi by dou z square. Now we may replace these three terms with the help of grade pi dot grade psi. Then these three terms by means of pi into del square psi. If you want to verify this, just to take the grade pi dot grade psi, grade pi dot grade psi is I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. This is grade pi. Dot grade psi I into dou psi by dou x plus j into dou psi by dou y plus k into dou psi by dou z. You may get I dot I 1. So dou pi by dou x dou psi by dou x plus j dot j 1 dou pi by dou y dou psi by dou y plus k dot k 1 dou pi by dou z then dou psi by dou z. We have had the three terms. Therefore, these three terms are replaced by grade pi dot grade psi. In the same manner, we may do this because del square is del dot del. The value of del square operator is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. See, pi into del square psi which is equal to pi into, so this operator is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. It is operating on psi. Then we can get pi into dou square psi by dou x square plus pi into dou square psi by dou y square plus pi into dou square psi by dou z square. Then this is our, these three terms are replaced by pi into del square psi. Therefore, we may write the values double integral of pi grade pi grade pi dot ds equal to pi dot grade psi dV, this value. This grade pi dot grade psi plus pi into del square psi into dV. Say this is our first Green's equation. You should provide your own later. First Green's equation. Now replace pi by psi. Now we can get psi, see here, this is pi grade psi, pi grade is grade psi. Now replace pi by psi, psi grade pi dot ds, which is equal to triple integral of grade psi dot grade pi plus psi into grade square pi into d. Find out 1 minus 2. That gives double integral of pi grade psi minus psi into grade pi dot ds, which is equal to triple integral of series grade pi dot grade psi minus of grade psi dot grade pi 0. Therefore pi square psi minus psi grade square pi into dV. This is our Green's theorem in the second form. With the help of the Green's theorem, we can study the boundary value problems in electrodynamics. This is first equation. This is second Green's equation.